I guess we can start now. So it's my pleasure to introduce our next company speaker. So Babak from Qualcomm is going to talk to us about what Qualcomm AI research is doing. Floor is yours.
Yeah, thank you, Mehdi, for the introduction. First of all, I want to thank the organizers for doing a brilliant job so far. I know Mehdi from, I think last year, Qualcomm Innovation Fellowship, or 2 years ago, actually.
2019.
Yes, 2020. Mehdi took part in the competition of the fellowship competition and won the fellowship award. And when I heard that they are organizing this summer school, people at Qualcomm as well were very supportive and very excited to support this basically effort. So I'm very happy to be presenting our work here and introducing some of the works that we are doing specifically in the Amsterdam office at Qualcomm AI Research. So as Mehdi said, I'm Babak Etishami Bejnordi. I'm a staff engineer and manager at Qualcomm. So to start, I would like to tell you a little bit of history about Qualcomm, because not everyone has heard about it. So Qualcomm has been a leader in the mobile innovation for over 30 years by inventing technologies that took us from the analog world to the digital world that we are in at the moment. We have redefined computing by connecting the first smartphone in the world to internet. And right now, with the era of 5G and edge computing, we are at the forefront of innovations to enable connecting virtually any device to millions of devices. So that is the core, basically, thing that Qualcomm is developing. So 5G is a major thing in there. And of course, producing chips that support AI is another major direction. But one thing that becomes incredibly important when you want to connect everything to each other using 5G is on-device intelligence. A lot of companies at the moment rely on cloud-based computation, but while cloud-based computation will remain important maybe forever, but I think they need to be complemented with on-device intelligence. This is for a number of reasons. For example, privacy is always an issue. For a lot of cases, you don't want to send sensitive data to the cloud. You want the devices you have to be inherently smart. Also, for several cases, reliability and latency is very important, as well as transmission efficiency and bandwidth utilization. For example, where you're driving a car autonomously, you don't want everything to be sensed and sent to the cloud, and you get a decision that you shouldn't hit the person. You want the devices in the car to be smart by themselves and make a decision in a matter of milliseconds. So that's why on-device intelligence is one of the core problems we work on at Qualcomm. And with that, I want to tell you a little bit about, in a very big picture, what are the areas that Qualcomm is using ML and in general deep learning for. So in principle, we focus on a lot of technologies that are maybe 3 to 10 years away from commercialization. In the center of that, at the moment at least, is 5G. And it is being considered that the next G, 6G, will not be a breakthrough in wireless itself, but it would be the combination of AI and 5G. So literally, we are already enabling connecting a device to millions of devices. We want everything to be connected in a smart way. So a lot of different things spin off from that. For example, industrial IoT will become an important application which requires ML or extended reality, vehicle to X, so vehicle to everything connection, autonomous driving, and Wi-Fi sensing, for example. But the particular topic that I will focus the most here will be deep learning and how we what type of projects we focus on for deep learning associated things. So from now on, I get away from the big Qualcomm and we'll focus only on the things that we do in the Amsterdam office. So in the Amsterdam office, we are actually, let me mute these because I don't want to bother you with a noise. So we are 7 teams in total. One of the major teams is the perception team, and they do anything related to perception, from efficient video processing, object detection, semantic segmentation, all these common perception tasks, wireless RF sensing. I want to show you one demo that was, I think, in NeurIPS this year, which shows you how you can run group equivariant convolutional neural networks on Qualcomm hardware, and what is the benefits of that compared to a conventional CNN. It is basically segmenting tumors tissue, in this case, breast cancer. And you see that on top, the results of the GCNN is significantly better because it is rotation invariant. So the areas that you see, green is true positive, yellow is false positive, and red, if you see that, they are false negatives. Another application that I wanted to show you is the Wi-Fi sensing project. In this project, some of my colleagues are working on self-supervised clustering algorithms based on deep learning to localize a human purely based on Wi-Fi signal. So no additional sensor is being used. And for example, this guy is walking in an office at Qualcomm, and they are able to locate his position purely in an unsupervised fashion. Another team in the Amsterdam office is focusing on virtual reality. So they in principle work on a lot of 3D topics, so point cloud analysis, 3D reconstruction. And another topic which is gaining a lot of importance is wireless AI. As I told you, 6G would be the combination of AI and 5G. They work on a lot of theoretical topics for their particular purposes. For example, they use graphical models or graph neural nets, or they also focus on learning physics of RF propagation. So a lot of diverse theoretical topics are covered there. Something I wanted to add actually is that the library that is being used for this demo, it is implemented by Gabriele Cesa, who is a colleague of mine. He's actually also in the summer school and at the booth now. And the code is and the entire equivariance library is available for you to get. And now I would like to go to tell you about the other 4 tracks. So we have also the source compression team. This team focuses a lot on generative modeling. So they basically try to design generative models for various tasks like video compression and audio compression. Here I want to show you actually, this is the first example of a neural video decoding in the world that was demonstrated last month, that is running on a commercial mobile device. So what we know that in a lot of applications, we are relying on a lot of video codecs which are handcrafted, like HEVC. These are extremely efficient and have been developed in the course of tens of years. And now this is one of the first examples that is relying purely on deep learning for decoding, so compressing videos in a real-time fashion. This was, I think, demoed last month in CVPR. Other teams in the Amsterdam office include the model efficiency teams, and that's a very large team. They mainly focus on neural network compression and quantization, also neural architecture search, NAS, and conditional computation. Let me stop this and show you the demo they had for. Okay, I do hear some noise, which we shouldn't hear. But essentially, they are, I'm not sure if this is playing. Okay, muted and play it again. So essentially, you can basically run we are running a semantic segmentation model on floating point 32 precision. And if you quantize this naively, you get a lot of false or misclassifications. And the authors proposed ADA round, which is a paper that was published in ICML 2020, and it went directly into our quantization library. And right now it is accessible by millions of developers to quantize their models for their specific deep learning applications. Other topics that we work on are including federated learning and personalization. You're probably aware of the GDPR, or General Data Protection Regulations in EU, which is affecting a lot of things that we do right now. For example, data could not easily go from Europe to US. And these are actually affecting machine learning aspects as well. For example, when you do distributed learning, when you do federated learning, privacy and taking into account these regulations are becoming increasingly important. And we are now seeing models that are being developed to provide guarantees to have a mathematical way of proving that the models are privacy proof. The other aspects is that because you do federated learning, each device is going to be a source of training. Therefore, efficiency of the models is a very important aspect as well. And finally, the last team is focusing on combinatorial optimization. So this is mostly working on a lot of theoretical problems, but at the same time, for example, focusing on solving the traveling salesman problem, a very well-known problem in combinatorial optimization. But one of the major applications is chip design. How do we place transistors and different cells and components of a chip in a way that it is being done in the most efficient placement on the chip. So as I wanted to show you how diverse the topics can be. We're covering basically a wide range of topics from perception to pure ML oriented topics. And with that, I also wanted to show you a slide in which I wanted to promote the Qualcomm Innovation Fellowship Program. This program is run basically every year, and we provide fellowship to the PhD students with the best proposals. If you're from one of these universities that are listed here, you can definitely apply and submit your proposals. Our next program for 2022 will actually, I think, starts around January, February. We generally send emails to the professors, so you should be informed from them. If you think that you're part of a large team and your university is not part of these, feel free to email me. I've put that at the end, so we may consider adding new universities to the list. So in general, students, let's consider the next paper you want to write or a novel idea that you have. They would submit their proposal. You don't really need results or anything, any experiments done for this proposal. You just need to propose something innovative. You get letters of recommendation from the faculty, and provide your CV and sign the official rules of document and participate. So this year, I think we had 4 winners, also from a lot of diverse topics. So if you're interested, just feel free to apply. And I think there is a $40K prize in dollars and a trip to San Diego, which I hope next year at least the winners can get to, because this year it was very tricky to send them to US. I've placed the link to this Innovation Fellowship, but in general, if you just Google Innovation Fellowship Qualcomm Europe, you should come to this link easily. Here are some extra links that I wanted to provide. So a link to the careers page. We have internship opportunities for the students, so feel free to check them out. You can also directly email me and inquire about internship opportunities. I've also placed links of the Qualcomm Innovation Fellowship and the contact address of them. And with that, I would like to thank you for your attention, and I'm very happy to take your questions now.
Thank you, Babak, for the great talk. Can we all thank our speaker? Thank you very much. And now we're going to take questions from the audience.
Sure.
So one question I had, perhaps it's more of a comment. So you were saying one of the missions that Qualcomm has, I mean, it was a huge, diverse, impressive thing, but one of them was working out where chips should go on a computer chip, like little components like transistors and so on.
Right.
And that seems to me more like an electronic engineering problem than a machine learning problem. So could you say a little bit about how machine learning sort of comes into it?
So Qualcomm has been relying on a lot of non-machine learning related efforts for placing chips, basically, so far. And the entire process seems to be extremely complicated. Even generating simulations of that is very complicated so far, as I understood from the people working on that topic. But in general, they rely heavily. So at some point they use some components inspired by electronics to create a sketch, but then there would be human engineers which manually do some designs to create an optimal solution, and those are extremely also slow, the processes. But then from what I understood, they would define they would define different components like cells, transistors, and they have different properties, of course. And one of the solutions they're investigating is to build a graph, so a graph neural network, and they kind of define the relationships between different chip components using the edges, and the vertices would be basically the major components like transistors. And they try to optimize this using combinatorial optimization techniques. From what I understood, there are a couple of companies right now focusing on this direction, but it is a very challenging one. So it might take a while before we hear a successful, purely independent AI-based placement of chips.
Thank you.
Do we have any other questions?
So I can think of one actually regarding what you mentioned, using GNS in wireless for error correction, I think on the previous slide. Is it more about networks of antennas or networks of sensors? Is it related to IoT? Can you tell us a little bit about this?
So this is actually a topic that they recently submitted the proposal. I don't have a very good overview of what that topic is, but I think it was for the problem of channel estimation in wireless. I really don't know the details. Sorry about that.
Okay, sorry, shouldn't have asked that question.
No. But I can definitely link you with a person that is leading that team, and he should be definitely able to provide more details.
All right. So do we have any other questions?
Yeah, I have a question. It's more curiosity, if I can.
Sure.
Can you hear me?
Yes.
Okay, great.
Yes, go ahead.
So I've done some quantization on computer vision, and I mean, I'm new to graph neural networks, and I wanted to know if, like, the techniques that you use for computer vision and so on, like, can move directly to graph neural networks, or you face problems, and if yes, what kind of problems?
So for graph neural nets, as far as I know, they have tried it on a wide range of applications. They have tried it for different perception tasks like segmentation, object detection. And I know that they tried it on natural language processing. They tried it on transformers. but I haven't heard anything about applying that on graph neural networks at the moment. But I think it might be that some adaptation will be needed. But in a lot of scenarios, they see that the models that are developed are working in a very straightforward fashion. But in some cases, there are specific layers that they need to redesign something. But in general, a lot of things seem to be very well quantized. But I think graph neural network is something that they haven't touched yet.
Okay, thanks. It's very interesting. Thank you.
Sure.
Okay, sounds good. So I think we may have time for one last question, but if there are no other questions, then I invite everyone to check out Qualcomm's booth in Gather Town. And yeah, so they have lots of interesting resources there. Oh, and also they're sponsoring the pub quiz that we have on Friday after the closing remarks. So thanks again, Qualcomm, for the very generous sponsorship. And I hope to see many people participate in this social event, which I think will be very fun. Tim here has prepared lots of very interesting questions for all of us to solve.
Yes, looking forward to that challenge.
Great. Thank you, Babak, again.
Yeah, thank you, everyone. Thanks.